Okay, so if we have SN1 or SN2,
SN2 prefers DMSO, and then SN1 would prefer the formic acid. No.
well, what are the characteristics of the solvents need to be?
Polar and
Non-polar.
Well, I think they both prefer polar, right? But SN1 is protic,
Yeah, and then SN2,
and SN2 is
aprotic.
aprotic. And why is that?
something about like the hydrogen bond. No. Something about the hydrogen bonds. Like the electronegativity won't pull off something.
So let's think of our SN or our substitution reaction with the alcohol.
Mm-hmm.
This is a secondary alcohol, so the derivative step was protonated. And what's the rate determining step in SN1?
It's the formation of the carbocation.
Yeah, like this falling off, and that's the rate determining step we form a carbocation. If we want to stabilize the carbocation, I mean, we're going to need, how do I say this? Since that's the rate determining step, alcohol's falling off, the water wants to attach like right back on. That's what slows the process down. But if we have things where we have, or if our solvent has hydrogen bond potential, if I see some oxygen, then this will keep that water from attaching back on. Likewise, if we have an SN1 with an alkyl halide, the rate determining step would be this guy falling off.
Mm-hmm. And you want to replace it with water.
Yeah, then you want these hydrogen bonds, even though it won't really be hydrogen bond with the bromine,
Right.
it's not technically, but you have all these hydrogens that like swarm around it, so it keeps it from attaching right back on.
Okay, because aprotic means that it won't form hydrogen bonds, correct?
Yeah, aprotic, there's no hydrogen bond potential. Whereas if we have SN2, let's say we have our nucleophile here, it wants to come in. If we had an aprotic solution, we have all. So the rate determining step in SN2 is this guy coming in, the halide leaving. But if we have all these hydrogens surrounding it, it's going to slow it down. I think of like in The Incredibles, how after he breaks in the computer and then all the black blobs like hit him,
Yeah.
slow him down. I think of that. Like all these hydrogen bonds are like attaching and swarming around him, and it slows him down from escaping.
Mm-hmm.
That's what would happen if the nucleophile is trying to come in. It's just going to be really slowed down. So we want it to be aprotic, so that way it's not slowing down the nucleophile from coming in.
Okay.
But everything needs to be polar because we're dealing with polar molecules, and like we're forming a carbocation here. There's just, if you're dealing with polar things, you want like dissolves like.
Right. Okay. So for on this one, you're kicking off a bromine and attaching an alcohol group. So you would use DMSO so that when the nucleophile, is water considered a nucleophile?
If it's acting as a nucleophile, yeah.
Yeah. So it's going in to replace the...
So if you're adding water to it, is it going to be an SN1 or an SN2?
Would be SN1.
So another thing here.
This would be an SN1 because it's going to be a tertiary carbon.
Exactly. This is one of the charts I make for chapter 8 is reactivity. For SN1, your tertiary was the most reactive, and then it decreased, right?
Yeah.
But SN2, it's opposite. Your methyl is greater than primary, it's greater than secondary, which. So your tertiary is your least reactive for SN2. So we're seeing this bromine here on a tertiary, and we're reacting it with water. Basically, we're going to say, oh, this is going to be an SN1. So we want it to be polar product. Now the thing is, water is usually the solvent, so this is usually solvolysis.
Yeah.
So I guess, I don't know, I'd probably say just put that in with water, and water will act as the solvent.
Yeah.
But is it saying you have to pick one?
Yeah, he says use formic acid or DMSO, and then explain.
So this one we'd want to use formic acid because this
Oh, you
one's
would?
going to be more likely to be SN1.
Oh, right, okay.
Because our rate determining step is the formation of carbocation.
Right.
So if it was a product, so polar product helps stabilize our transition state.
Are you
So
using
that's
sarcasm as well?
Mm-hmm.
That's 2A, right?
Yeah.
Does that make sense why this one would be SN1 and why we use formic acid?
Why would you use formic acid?
So, do you understand like why this is SN1
Can you
right
draw
here?
the formic acid?
Yeah, formic acid looks like this.
Okay.
Formic acid is an example of a polar protic
Uh-huh.
solution. So, since this is SN1, we want it to be polar protic, so we'll use
Okay.
formic acid. Because again, on an SN1, our rate determining step is a bromine leaving.
Mm-hmm.
So we have this bromine here. The hydrogens from our formic acid help kind of keep that bromine from reattaching.
Mm-hmm.
Now the next one, it's ethyl iodide.
Ethyl iodide? Dude. Ethyl iodide. What are you reacting with?
Sodium CN. Is that cyanide?
Yeah, so you're really reacting with cyanide, right?
Yeah.
Which one's this?
This is 2B for the homework today.
So 2A was the
Formic
first one
acid.
before.
Yeah, as formic acid, you said it's because polar-protic helps stabilize the transition state.
Mm-hmm. Because SN1 would be more favored. I put because SN1 would be more favored. You want your
Okay.
solvent to be polar protic on A.